Let's continue our discussion of statistics and look at percentiles or percentile rank. What that is it basically shows the percent of the data that's lying below an individual observation. Okay? We can denote this by P sub r as percentile rank at level R. So I'll kind of show you some examples here so we can follow that. For example, let's look at the Iowa Test of Basic Skills, formerly known as the Iowa Test for Educational Development, or ITEDS. And let's say a particular student is a 9th grader, and they got a score of 99th percentile in math, 85th percentile in science, and 56th percentile in English. Now, I believe English is broken up to vocabulary and comprehension, etc., but maybe this is the cumulative English score. Okay, so a lot of parents get this in the mail and they have no idea what that means. So what statisticians have done is they've tried to then give a grade equivalent to this as well. So the grade equivalent for math for this particular student is 14.2. Well, if you realize that 12 grades means you graduate after 12th grade, then this really means this student would have the math skills measured approximately 2.2 years after graduation. In other words, basically sophomore in college and maybe the beginning of junior year in college. But certainly they've got enough math skills according to this test that they would be equivalent to a completion of sophomore year in college. For science, that grade equivalent was 11.1, meaning basically it's like they're got comprehension in junior year. Of course, 85th percentile means 85% of the data or of the students taking these tests in the state of Iowa scored below that student. So we expect that these are two excellent scores on the Iowa Test of Basic Skills, and their grade equivalent is higher than their freshman year. Now in English, this score isn't quite as good. It's kind of middle of the road, right? 56% of the students would score below this particular student, which they're still in the upper half of the data. However, maybe the grade equivalent here is 8.7. So that kind of means they're right on target. They're actually a little bit below 9th grade. It means they're toward the end of 8th grade. And so that's what statisticians get paid to do, apparently, is take numbers like these and turn it into a grade equivalent. So I do try and explain that to my students when they get this, just to be aware, and to their mother as well, who doesn't really care about the statistics. She just cares about our children being prepared and getting good grades, etc. So if we come back and put the notation P sub r here for the math score on the 99th percentile, P sub r would be P sub 99 here. And anyway, P sub 85 would be the science score, and P sub 56 would be the notation for the percentile that we have here for each one. I do want to make one note. One thing that drove me crazy in the math world is I always like to get 100% on my tests, and anytime I took the Iowa Test for Educational Development back in the day, I could never get 100%. And I just couldn't understand that. I'd go through those tests and I'm like, I didn't miss any. I know I didn't miss any, so I wanted to see those tests. Of course, they never let you see them again. So I couldn't figure out what I missed. Well, as a kid, I didn't really understand that this means that 99% of the observations were below me, but at that same point in time, that means there is no P sub 100. In other words, you can't have 100% of the data lie below you, because you wouldn't be one of the observations. You'd be out of bounds, so to speak. So the highest percentile to the nearest 1, which is how they do it, is P sub 99, or the 99th percentile. Okay, so that gives a nice example of percentile rank and a particular student on test results there. So now let's take this and let's apply it to class rank. So let's look at another example. Let's take Jim, who actually has a rank of 15th in his class. And then let's take Bob, and let's say he has a rank of 10th in his class. Okay, so of course class rank is a little bit different. Class rank says that there are only 14 students above Jim okay, and he's 15th in the pecking line, maybe of GPA or those types of things. Bob has a rank of 10th, so he could put on his college resume that, hey, I'm in the top 10 in my class. Okay, the question might be, comparatively, who might be better? Well, instinctively, it may seem that Bob is better because he's got a higher rank and he's higher up the list or closer to the top. However, what's important here is how many students are in that class. Okay, so what we can do, let's say that Jim has a rank of 15th and there's 150 students in his class, and Bob's rank is 10th and there's only 50 students in his class. Okay, so 15th out of 150 basically is 10%. Okay, so there's only 10% above, which means there's 90% below. So this gives a percentile rank of piece of 90 or 90th percentile. Okay. 90th percentile for Jim. Similarly here, 10 divided by 50 is 20%. Once again, he would be in the top 20%. So that means 80%, or 40 divided by 50 would be 80%. So this would be piece of 80. So the 80th percentile would be Bob's percentile rank. So now we have a measure, instead of just the number of the rank they're in there. You know, Jim's class was 3 times as big, so his rank is actually 90th percentile versus Bob's being at the 80th percentile. Now we can also use this and say if a student has a certain ranking, a certain percentile, what would the ranking be? So let's look at Sue here, and let's say that Sue has, we know she's got a percentile rank of 60. What does that mean again? That means that 60% of the students lie below her in her rank, and let's find out what her class rank is. Okay, well, to do that we need to know how many students there are in the class if we don't know her rank. But if we know that there's 80 students total, then what we can do is we can take 60% of 80, and that's 48. So 60% times 80, 0.6 times 80 is 48 students. But what does that mean? 48 students do what? 48 students actually lie below her, right? So 0.6 times 80 is 48 students lie below. So then to get her actual class rank, we simply just take 80 minus 48, and we're going to get 32. So basically she has a class rank of 32nd. So if we know the percentile rank for that student and how many total there are, we could also find out the rank of that individual observation, in this case Sue's rank. So remember, 60th percentile, she is in the upper half, and then so this makes sense because half of 80 is 40, so she would be in the top half there. So she should have a rank that's less than 40 since she's in the top half, and so she's 32nd in her class. So number 1 being the best, and then she's 32nd all the way down to 80th being last. Okay, so that's some things that we can do with percentiles, percentile ranks, and then individual ranks in a class. Just a few other notes. We do have some other things called deciles. Deciles are just particular observations here that try and split up into tens. We like to use powers of 10. So deciles is just nothing more than taking data and splitting it into tenths. So we kind of did the 5-number summary in the past. We split it into fourths. Deciles is just trying to take data and split it into tenths. So the first decile, which is called D1, is actually nothing more than piece of 10. It's the 10th percentile. So 10% of the data would lie below that observation. Okay, D2, the second decile, is basically the 20th percentile. Once again, 20% of the data would lie below that observation. And we can go all the way up to the 9th decile is piece of 90. 90% of the data would lie less than that. And of course, you can't have a 100th percentile, as I mentioned before. So if you're above the 9th decile, that's the top 10%, okay, if you have an observation there. So we could split into deciles, and then of course, you know, so basically we just have the max at the top here instead of the 10th decile. We have the min here would be the lowest one where 0% lie below that. So we got the max and min, and then the 9 deciles splitting it up into 100% into each of the 10% here. So we do have that. And then last but not least, let's go back to our example with the ACT scores. If you recall that one, you know, we had ACT scores we had from a previous couple of videos. We had 21 was the mean. We said this was a normal distribution with a mean of 21 and a standard deviation of 5. So if we go one standard deviation away here, then that's 26, and this would be 16. So I could ask a few questions here. First of all, what's P sub 50, the 50th percentile for this? Well, once again, 50% would lie below, so that would be half would lie to the left of the mean, correct? So the 50th percentile is actually a score of 21. So 21 would create the 50th percentile. We could have a few other things. If I said, what is the percentile for 26, what area lies to the left of 26? Okay, well, we know there's 50% here, but then we also know that right here, we can use the 68, 95, 99, 7 rule. And of course, 68% of the data lies within one standard deviation of the mean. So if we split that into 2, we've got 34 and 34. So there's 34% of the data lie between 21 and 26, plus the 50% that's over here. Then we can say that the 84% lie below the observation of 26, so that's the 84th percentile, P sub 84. Okay, and then we can also do one more here. I'll redraw the picture here, but once again, we've got 21 in the middle. We have 16 here. What if I say, what is the percentile rank for somebody that got 16 for the score? Well, you would expect it to be less than half, because less than half of the data lies below this observation. But what we can do is we can say 68, 95, 99, 7 rule, there's 34% here, there's 34% there. We know that this half is 50%. So to find this percent lying to the left is just going to be 50 minus 34. And so that ends up being 16% lies to the left of the observation, in this case of 16. So the 16th percentile is actually 16 here. Another way we could do that, just to draw another quick picture, another way we could do that with 21 here, if I know that between 16 and 26 that I have 68% of the data, and then I want to know what this tail is, then basically I can just say this tail is 100% would be the whole thing minus 68, and then divided by 2 tails, because I've got a tail on that side, I also have a tail on this side. So the whole thing's 100, subtract the central probability of 68%, and then divided by 2, because I got one on each side, because all I want is what's left. So 32 divided by 2 is also that 16%, which is that 16th percentile. So that's a good summary of percentile, percentile rank, and deciles.